Hello everybody, I hope everyone is having a great day so far. Today we are going to talk about operations with radicals. Now remember, a radical is basically a square root. Okay, now it's not just a square root, we also have other radicals, or this, we see this sign, I should say, in other situations where we do cube roots or fourth roots. But for the most part, for our terms right now, a radical is pretty much a square root sign. Okay, if you don't see an index, the index is 2, meaning that you're taking the square root. Okay, you won't see an index when we are taking the square root of things, so that means the index is 2. So there's an invisible 2 there, just like there is a coefficient of 1 in front of a variable if you don't see one, or an exponent of 1 if you don't see one. Now, in talking about operations with radicals, the first thing we need is our perfect squares. So let me just write these down for you. So here on the right hand side I wrote down a short list of some perfect squares. Very easy to get your perfect squares. You just take numbers 1 through whatever and multiply them by themselves, and then your answers are your perfect squares. Okay, so before we talk about operation with radicals, I want to review simplifying radicals. For most of us, again, this is a very good review because we've done this already and it's tested on your Keystone exam. Some of the questions are a little more detailed, but let's say we have the square root of 54, and I'm asked to simplify that. Well, 54 is not a perfect square, meaning we can't take the square root of it evenly. So the quickest way to simplify a square root is to ask ourselves, what is the biggest perfect square that divides evenly into 54? Because I want to find the biggest perfect square factor of 54. And if I look at my list and try some possibilities, the biggest one that goes into 54 that divides evenly into it is 9. And 9 times 6 gives me 54 back. So once I rewrite 54 as 9 times 6, now I take the square root of the perfect square. The square root of 9 is 3, so my final answer is 3 root 6. When you take the square root of a number, it goes on the outside of your radical, and the number that you couldn't take the square root of evenly stays underneath your radical. Okay, so this is an exact answer. So that's a quick review of simplifying. Now let's move on to multiplying radicals. So for multiplying radicals, we could really multiply most radical problems together. In algebra and math in general, there is more strict rules for adding and subtracting than there is multiplying. Multiplication is a little bit easier to do for anything you have. So most problems you will be able to multiply together. First, what you're going to do is you're going to multiply. And after you multiply, then you're going to simplify just like we did in the review. So let me give you a couple examples of this. Let's say we have, we'll start off very simple, root 3 times root 6. Okay. Well, I can multiply the radicands together. That radicands are numbers underneath my square roots. 3 times 6 is 18, but I keep my answer underneath the square root. So if the two things I'm multiplying both are underneath the square root, I multiply them together and keep my answer underneath the square root. And now finally, I take my final answer and simplify. So using my perfect squares, which are on the previous slide, so if you go back in the video if you need to, the biggest perfect square divided into 18 is actually once again 9. So we rewrite 18 as 9 times 2, because 9 times 2 gives me 18 back. And I take the square root of the biggest perfect square factor of 18. So the square root of 9 is 3. So my final answer is 3 root 2. Okay, so for our second problem, we have 3 root 10 times negative 2 times the square root of 5. So for this particular problem, we actually have coefficients in front of each square root. Okay, so what do we do here? Well, first, we actually times the coefficients, or the numbers on the outside of the radicals together, and we get negative 6. Okay, and then next, I times the two numbers underneath the square root, or the radicands, and I keep my answer underneath the square root, and I get root 50. So let me just pause for a second here. When you're multiplying radicals together, you can multiply numbers on the outside, and my answer stays on the outside. Okay, I could also multiply numbers underneath the radical or radicands, and my answer keeps the radicand for the first part. Okay, so that's the rules and basic rule in multiplying roots together. Now, after I multiply, I have to simplify. So looking at root 50, the biggest perfect square that goes into root 50, if I write a couple down, is actually going to be 25. Okay, so I could rewrite root 50 as 25 times 2. In essence, for right now, we're forgetting about the negative 6 on the outside being multiplied to the problem. The square root of 25 is 5. That goes on the outside of my root, and the 2, stays underneath my square root. Now for my final answer, remember this is all the work for just the square root of 50. I multiply the 5 I put on the outside by the negative 6 that was on the outside. So I multiply these two numbers together, and my final answer would be negative 30 root 2. Okay, so again, 2 steps for a multiplication problem. First, you multiply your radicals, and then you simplify. For our next example here, we have 4 root 12 times root 2. Now, a couple things here. If I insist upon having a number in front of my square root, you can. The number that would be in front of this square root being multiplied to this particular problem right here would be a 1. Just like in algebra, if we have a variable, right, there's a 1 in front of it, okay, being multiplied to it, the coefficient. So same type of principle here. So you could always write a number in front of the root if you want to. So I can multiply these two together or just keep the 4. So 4 stays on the outside. I multiply my radicands together and I get root 24. Okay. Now that I multiplied, I have to simplify. The biggest perfect square that divides evenly into 24 is 4. So I'm going to rewrite 24 as 4 times 6. I take the square root of the perfect square and I get 2. So 2 root 6 would be my final answer if I was just simplifying root 24. But remember, we had that 4 on the outside of the problem, so I have to multiply the 4 into 2, and I get my final answer of 8 root 6. So I actually titled this lesson Operations with Radicals, but for sake of time, I'm actually just going to keep it a lesson on multiplying radicals. So at this point, what I'm going to do is I'm going to give you 3 questions to try on your own. So when you see these questions, go ahead and write them down in your notebook, try them, and then pause the video, and after you are done, check your answers to see how you did. Okay, so here are your 3 problems to multiply. So first, multiply, and then make sure you simplify your answer. That's the easiest and best way to multiply and simplify radicals. Okay, so pause the video, do the problems, and then check your answers. So I'm going to have a brief intermission for 10 seconds. Okay, hopefully you paused the video. If you didn't, go ahead and pause it now and do the problems, but let's go over the answers. For the first one, we multiply the radicands and we get root 45. Now I have to simplify. The biggest perfect square that goes into 45 is 9. So I rewrite 45 as 9 times 5. And the square root of 9 is 3, so my final answer is 3 root 5. For the second one, if we really want to, we could write a 1 in front of this radicand. So I can multiply the numbers on the outside and I get 5. I multiply my radicands and I get 49, so 5 root 49. Now again, after we multiply, let me just draw a line here to separate the problems. After we multiply, we have to simplify, and 49 is actually a perfect square. So what happens here is I don't have to write it as 2 numbers multiplied together. I could just take the square root of 49 and I got 7 without a square root. So therefore I multiply it to 5 and my final answer is 35. And that one's a little bit different than some of the other problems because the number underneath the radical after we multiply it is a perfect square. And finally the last one, negative 6 times 2 is negative 12. I multiply my radicands together and I get root 48. And now I have to simplify. The biggest perfect square that goes into 48 is 16, so I rewrite 48 as 16 times 3 underneath my square root. The square root of 16 is 4, so I have a 4 on the outside and a 3 underneath my radical. And now for my final answer, I multiply the negative 12 that was out there to the 4 I put out there when I took the square root of 16. My final answer is negative 48 root 3. Okay, I'm running out of a little space there. Final answer is negative 48 times the square root of 3. So hopefully you found this lesson helpful. Please go back if you had any questions, and make sure you answered the questions throughout the video. And please come in and let me know if you have any questions. Thank you very much, and have a fantastic day.